you look at the picture itself, a couple very interesting elements. First of all, the sun has a face on it. I don't think that's really significant. It might be. I don't know. But it's looking down upon creation and at this person who's poking his head through a dome-like object. And this dome-like object here is what they are calling the crystal sphere. And like I said, this is called breaking through the crystal sphere, is what it's commonly known. And as this person breaks out of the crystal sphere, they look out into what is the universe. And they see all sorts of crazy things out there. They see clouds, they see other stars, they see the sun, and they see wheels, all sorts of wild stuff out there in the universe that this person is starting to see by looking through this crystal sphere. Now, we don't know who the artist is, but we can infer several things about the artist. The artist, first of all, it appears believed in a flat Earth. As you can see, the plane there is flat. We can also infer that this artist very well may have believed in an ancient model of the universe. And what this model depicted was that the universe was encapsulated by multiple spheres. I'm going to talk about that more here in a minute, but I'm going to save it for the next couple slides. And Matt, you can go ahead and switch slides there. First, we're going to talk about the expanding universe itself. I'd like to ask the question, is the universe really expanding? My conclusion is, I really don't know. That might sound like a weak answer for a book called 10 Irrefutable Proofs of Creation that uses the expanding universe as one of the irrefutable proofs of creation. But quite frankly, no, I really don't know if the universe is expanding. I don't know if anybody truly knows. A lot of people are confident, but I don't know that anybody truly knows if the universe is really even expanding. Why do we believe the universe is expanding? In one sense, it's in large part because of the Big Bang model of the universe. A lot of scientists have espoused the Big Bang as their model to explain origins. And it only makes sense that if the Big Bang, we call it the Big Bang because some people will say it was an explosion, but that's scientifically inaccurate. It was an expansion of space, is what they would say. And if the universe is a result of a rapid expansion of space, it can only be expected that the universe is moving outward. Clearly not inward. That'd be a problem if it was. But the universe is moving outward as a result of this Big Bang. So that's one point regarding why they believe the universe is expanding. But that, I would say, is more so derived from a phenomenon that's called redshift. It's sort of a red type of effect that's created as we look at the stars. And the way to explain a redshift is without using color at all, actually. When we think of a redshift, think of when you hear a train in the distance. As it's approaching you and it's blowing its horn, and as it approaches you, the pitch of the train's horn gets higher and higher. And then as it passes you, the pitch of the train's horn gets lower and lower. So as it was approaching you, the frequency of the sound waves, the frequency was getting higher, and we'll leave it at that for right now. The frequency is getting higher, which caused the higher pitch. And as it moves away from you, the frequency becomes lower and lower, and the wavelength, there we go, that's what I was looking for. The wavelength gets longer and longer as it gets further away from you, creating the lower effect to the pitch. Well, same thing with the red shift here. With the red shift, as things get closer and closer, they take upon a more bluish sort of tint. But as they get further and further away, they take on a red sort of tint. And again, this deals with wavelength and all that in the photoelectric spectrum. Kind of a complicated concept, but not really. Regardless, that's probably the best way to really explain the red shift. And because we see this red shift in the stars as we look at them, that is why we think that the universe is expanding, because it doesn't appear that anything is moving closer to us. Very, very interesting. You can go ahead and change slides. I'd like to talk about the history of man's understanding of the universe, and this will ultimately bring us to the expansion of the universe as well. But it'll help us to understand, why am I not so sure whether the universe is expanding or not? Let's go back to the 6th century BC. A man named Pythagoras. You might recognize his name from the Pythagorean theorem. I can't remember what type of triangles it's used to describe, but it's used to describe certain types of triangles. With Pythagoras, he became very curious about the universe. And as he made observations of the universe, ultimately this took him to the heavens. He looks out in the heavens and he sees the moon, and he's able to study the moon. There's not a lot of heavenly bodies, so to speak, that you can really readily observe, but the moon was one. And so he looked at the moon. He saw how the light reacted with the moon and the shadows and all that. And he saw that with the moon, the shadows were more consistent with that of a sphere than what it would be a projection or a flat object. And so he ultimately deduced that the moon was round, first of all. And then as he made more and more observations, he also deduced that the earth was round too. This was 6th century BC, and I know that the common concept in our culture is in 1492, Columbus sailed the ocean blue, and Christopher Columbus proved the world was round. Well, no, it was actually started in the 6th century BC with Pythagoras, a long, long time ago. 200 years later, a man named Aristotle. I'm sure that a couple of you probably are familiar with Aristotle. He's a Greek philosopher. He made similar observations of what Pythagoras did. And I would say that he confirmed that the world was round. But that wasn't enough for Aristotle. He had to look further into the universe. Where are we? What are we? So forth. And he started developing a model based off of his observations. And I can't remember if it's officially called the Geocentric Model or not, but it's at least what ended up as the Geocentric Model. And when I say geocentric, what I'm saying is Earth-centered. So when you hear about, when we talk later on about Galileo and Copernicus, when you hear that they proved that the Earth was not the center of the universe, this is where that started. It was back with Aristotle in the 4th century BC. So quite a while ago. And he actually devised a very elaborate model despite his limited ability to make observations of the heavens and the earth. Well, 400 years later, no, I'm sorry, 600 years. I can't do math. That's why we have Katie here. 600 years later, a man named Ptolemy steps on the scene. And he looked at Aristotle's model and he realized there was problems with it. So he made corrections to Aristotle's model to make sense of some of the phenomena that he was noticing, that some of the problems that Aristotle could not quite figure out. In fact, Ptolemy determined that there was 55 concentric spheres of the universe, all of which are our solar system. We have to remind around that. And the problem that he saw was that the planets didn't quite rotate the way that they should, given Aristotle's model. And so he proposed that upon attached to each one of these spheres is a ring type of object, and on that ring type of object was whatever it was that was supposed to be fixed on that sphere, say like the sun or the moon. And then on that ring that was attached to the sphere, that body rotated around the sphere on that ring, or to some effect like that. Honestly, I'm not too concerned if I get any of this part wrong, because all it's wrong anyway. And that all the observations that these guys made were great observations, but they weren't able to construct an accurate model. Enter Copernicus. Now I want to point something out before we start talking about Copernicus, because with Copernicus, at that time, the church had adopted the geocentric model. I also want to point out that they did not derive their model of the universe from what the Bible said, but what these ancient Greek philosophers had proposed. And so the geocentric model and the earth being the center of the universe, that all originated actually with pagan philosophy. It's very interesting to think about that. So Copernicus comes on the scene, and the church has adopted this model, and he says, you know what? From my observations, from everything that I'm noticing, it does not look like the Earth is the center of the universe. It looks like that the Earth is actually going around the sun, as well as these other planets. as you can remember from stories in school, this created a huge uproar, and ultimately he ended up recanting because of all the pressure that was put on him. Around the time that Copernicus died, another man was born. Go ahead and switch slides here. This man's name was Galileo. Galileo was a little bit more of a troublemaker than what Copernicus was, and he was not willing so much to recant. He actually confirmed what we now know as the heliocentric model, which is that the sun is the center, not of the universe, by the way, but of the solar system. And this all happened around between the mid-1500s and mid-1600s. I just use the general time frame from when Galileo was born to his death. So a lot of progress made right there, but not a lot of people willing to accept what they're proposing because it went outside of their societal norms. It made them very uncomfortable to think that the Earth was not the center of the universe. And we'll talk a little bit more about that after we're done with this brief history. We fast forward a couple hundred more years to Albert Einstein. Albert Einstein, smart guy. His name's synonymous with genius. If you're known as an Einstein, you're known as a genius. Albert Einstein proposed that the universe was static. When I say static, I mean that the universe does not change. It does not grow. It does not shrink. It stays as it is. And as a result of the static universe, he also proposed to make sense of his model of the universe, this constant known as the cosmological constant. It's a very interesting number because basically what it does, I don't fully understand. It's a very complicated concept, but it basically helps us to understand why the universe does not collapse on itself, granted how much energy exists inside the universe. I don't fully understand it either, so if you're confused right there, join the crowd. At the same time that Albert Einstein was alive was a man named Edwin Hubble. His name probably sounds kind of familiar too. Now, we don't know him on the same lines as Einstein, but we know him for not inventing the Hubble telescope per se, but his name is attached to the Hubble telescope. And Edwin Hubble was the first one to history's knowledge to notice that the universe was expanding. This created quite a dilemma for Einstein because his model depended on a static universe. Well, then Albert Einstein made a very interesting confession, namely that his cosmological constant that basically held the universe together, this static universe together, he said, you know what, I just made that up. I mean, my calculations didn't make any sense. I needed something, and this made sense of it. I made it up. Okay? So, throw out the cosmological constant right there. Edwin Hubble's model of the expanding universe then took precedence over anything else. That's not the end of it. Sorry, it's okay to switch it right there. You're good. That's not the end of that discussion, though. You fast forward to the end of the 20th century, and the Big Bang model, I don't know if everybody's familiar with this, but the Big Bang model doesn't always hold up to scrutiny. It was running into some very serious problems with planets not spinning in the way that the Big Bang model would predict them to spin. Law of angular momentum is what is used to describe those sorts of phenomena. Not them spinning the wrong way, but they're defying angular momentum. And because of that, they weren't quite sure how can we keep the Big Bang model and have the expanding universe and have these planets that are spinning in the opposite direction from which they should be spinning according to our model. Enter, once again, the cosmological constant. So now we have the expanding universe and the cosmological constant combined into one model, and the cosmological constant is there to be able to explain the existence of dark matter and dark energy, which if you don't understand exactly what those are, just think of pixies and fairy tales, because that's about what it is. Not to say they don't exist, but because there's no way to measure them, there's no way to know that they're there aside from calculations and mathematical models. So is the universe expanding? Well, they just introduced a constant to explain certain phenomena in the universe that requires a static universe that's inside of an expanding universe. And I'm no mathematician or physicist or anything like that, but that doesn't make a whole lot of sense to me.